Science 20, we're back. All right. We're going to continue with our look at geology by looking at some theories on how the Earth was formed, and then talk about the rock cycle. So, one of the earlier theories was catastrophism. This is the idea that major disasters such as earthquakes, floods, and tsunamis helped form the Earth. When this was generally accepted, it fit with our own human experience, and it also coincided with the belief that the Earth was only several thousand years old, basically as long as we can uh, have record of it. Uniformitarianism. This is the idea that geological processes that are in action today have always operated throughout the Earth's history. This was proposed by the father of modern geology. That would be James Hutton, and fits with the law of superposition. And Darwin had a good bit of influence with that. Now, to help explain this idea in more detail, we need to understand the rock cycle. So Hutton proposed that the Earth's geological processes were self-sustained systems. He basically talked about that there was a fire deep under the Earth's surface that provides a perpetual energy source and creates and destroys material from the Earth's crust. Now, we know that we don't actually create or destroy material. We're just transforming them from one state to another. But that's kind of what he meant by creating and destroying. So we have three main types of rock. We have the sedimentary rock, which is just layers of eroded fragments that just kind of have sediment deposit on them and compressed. Um, we have igneous rocks, which form from molten magma that come out through the mantle, get onto the crust or the surface, and then cools off. And then the metamorphic rock is where we take sedimentary or igneous rock and transform it at the molecular level due to intense pressure or heat. So, sedimentary rocks are usually formed at the Earth's surface under relatively low temperatures. Igneous is formed deep within the Earth's crust and mantle and happens under extreme heat. And we just need to remember that the whole mantle is made up of igneous rock. And then the metamorphic rocks are often found at the site of collisions between crustal plates, because that's where we're going to see a lot of that pressure coming in here. So the rock cycle just basically goes from one rock type to another. And so we'll take a look at what that means here. Now, please note, there's different ways that we can look at this, but everywhere we go, we can see how these different forms of rock are going to feed into each other. I'm not really sure where to start, so let's start with the molten magma. This is within the Earth's mantle, and it will kind of rise up uh, out of the volcano, cool, and solidify on or near the surface of the Earth, forming igneous rock. You can usually tell you have igneous rock when you see all these little bubbles within it. That's just the cooled off magma. Igneous rock. So we start with this igneous rock. Igneous rock will then be eroded by the weather, forming the sediments. The sediments will then layer themselves as they get deposited, compressing or being compressed by the upper layers, and thus forming sedimentary rock. The sedimentary rock and igneous rock can both, through extreme heat and or pressure, get converted into metamorphic rock. And metamorphic rock and igneous rock and sedimentary rock can get eroded, making more sediments, but also all three are eventually going to melt and return to the mantle as magma. So we can actually convert one type of rock into another. Now, the energy for this cycle is provided by the nuclear reactions that happen in the Earth's core. Just a quick summary of what a nuclear reaction is. In a physical reaction, we see matter maintain its formula, but just change states going from liquid to gas. Okay, evaporation of water. That would be a chemical reaction or a physical reaction. A chemical reaction is where you would have something like sodium solid plus chlorine gas is going to give us NaCl, which is just table salt. Now, this is a chemical reaction. The elements don't change, but they're rearranged in different orders, giving us different chemicals. Well, when a nuclear reaction occurs, what we end up with are different elements that are being produced. So you may start with uranium, and then that uranium can break up into two smaller groups of elements. So I'm just going to draw these here. This is just going to be group one, and this is going to be group two. All right. In your notes, I want you to draw a copy of the rock cycle. And if you have any, and work on these questions that are being given to you. If you have any questions, let me know, and I'll see you in the next lesson video.